Hello, my name is Jacob Willoughby, and I'm the CTO at Storj, or Storj, if you're Finnish. And I really had a good legacy database joke, but it really didn't scale. So I really want to talk about how we are accomplishing the impossible with CockroachDB in order to, in cloud object storage. So what do I mean by impossible? Well, what if I told you that we were going head-to-head with one of the largest hyperscalers, building a cloud object storage solution that was twice as performant, 80% less cost, and also 80% lower carbon footprint. And we're just a startup. So that's what we're doing, and that's what we set out to do. So I want to tell us a little bit about who we are and what we do, our database requirements. How does CockroachDB stack up, and why did we end up picking CockroachDB? I'll then walk through a few success stories and just kind of things that we learned along the way, and go ahead and wrap that up. Who am I? I've worked in decentralized object storage for about 10 years, so I actually did it way before it was cool. And I started with a little company called Space Monkey that just connected basically NAS devices and connected them together to build object storage. And then I worked for several years at Vivint Smart Home to connect 300,000 different devices, 600 petabytes of capacity, building decentralized object storage for Vivint Smart Home, and ended up at Storj 2 years ago. Storj, the fundamental concept of Storj is we wanted to build cloud storage in a different way. The vision when we were founded 8 years ago is most of the storage around the globe is underutilized. Like all those drives sitting there are only 20% full. What if we could take those and use that excess capacity and build a cohesive object storage layer on top of it using software? And so it sounds kind of familiar, it's kind of like AirBnB, but for data storage. And so I'm going to play a little video kind of explaining and showing what we do. So we first encrypt and store your data and distribute it around the globe. And then that data, wherever it's stored, is basically local to you wherever you are. So we store it all around there. And when we pull the file back, we only need a subset of those pieces. And the advantage of this as well is that you don't need to store multiple copies of your data in multiple regions. So if you want good performance in Europe and you want good performance in the US, on S3 or other platforms, you usually have to store multiple copies of your data to be able to distribute it in a performant way. But on us, in a single storage tier, you're able to get that. So we built object storage in a fundamentally different way. And we are also able, in a multi-cloud or an on-prem environment, unlock stranded capacity that's in your enterprise. So if you have multiple storage locations, if you have old hardware, we're able to load our software on that, and that hardware can then contribute to making a cloud object storage that's S3 API compatible within your organization as well. And so organizations love this because they come to us and say, well, I already bought, paid, and spent all this money on this hardware that's sitting there only 20% used. You're telling me I can use that other 80% and do something like globally distributed backups of all of my data? Yes, that's what we do. And so you don't have to purchase new hardware, purchase new cluster. You can use what we have. And so this is actually a picture of our actual footprint. We have 22,000 points of presence around the globe that we currently store data on. And these are tier 1, 2, and 3 data centers or prosumers that just offer up their excess capacity around the globe. And then we also have tiers of storage that can do things like SOC compatibility and also data sovereignty requirements. So that's quite a bit about us. I want to talk a little bit more about how we use CockroachDB in all of this in order to accomplish what we want to do. So we really have 3 key elements of our system. We have the storage nodes that are those 22,000 distributed around the globe that are offering up their excess capacity to our network. And then we have something that's called the satellite, which is our metadata and coordination layer. So we need to keep track of all of those tens of thousands, tens of billions of pieces that we distribute across the globe. And what do we do that with? We do that with CockroachDB. So all of that is stored in CockroachDB, and that's how we keep track of those pieces. That's how we monitor them to make sure they're all online. And then we can bring those pieces back together, repair them, and push them out, all using CockroachDB to orchestrate all of that. And beyond that, our satellite is also our billing and user management layer. And so our entire stack is built on CockroachDB for that layer. And then we also, of course, have our S3 API, and that's that uplink or those clients that are able to interface with this network. We started with a fundamentally different model because we are distributing the data globally. So the first step in ours is we built end-to-end encryption, which is different from any other provider. We ourselves do not have access to the data that you store with us. And then we encode and split that data into many pieces, say 100, and distribute them around the globe. But we only need a fraction of those, say 30, to re-encode and get your file back. And so that's kind of the flow for uploading data is encrypt, encode, and pick nodes and distribute it. And then to download your data, it's just the inverse of that. We go fetch the metadata from Cockroach, we identify which nodes they are, we go and download those pieces, reassemble the file, and decrypt it as the final step. So we're gonna do the thing you should never do in a presentation, which is a live demo, okay? And so let's all give this a chance. You can pull out your phone right now and scan this QR code. And I'll give you about 10, 15 seconds to get that scanned. Hopefully in the back, the TVs work for this. And then we should all be able to see the same globe doing uploads to storage at the same time. So let's go ahead and switch over and see if we can pull it up here. And so everybody should be seeing the same color of things spinning out of the globe, and you should be able to pan around and look around on that. So what is this doing? So this is just a simple server sitting there every 6 seconds uploading a file to the storage network, and then going and identifying nodes to store it to, and then storing that data, encrypting, erasure coding, and storing it across those live, and keeping track of which IP addresses it sent it to, and then geolocating those IP addresses and animating it on the map, with the metadata being stored in our Cockroach cluster as well. So this is all happening live. This is a live demo of the server that just sits there all day uploading files to the things. You can pull up anytime. Did it work? Was everybody able to see the globe and things? Yes, the live demo worked. We can go ahead and switch back. Thanks. Okay, so that's enough about kind of what we do. So I kind of want to go back and tell a little bit about our history and how we got to where we are today. So in 2018, we kind of had a greenfield project to do a new version of our cloud object storage layer. We knew, as I said before, we have 10 years and a lot of experience in building these systems. So we knew that at the outset that we needed to have certain characteristics for our metadata layer. We wanted to have horizontal scalability, and we wanted to have great performance. Every millisecond counts, and strong consistency. Normally in engineering, it's an error to prematurely optimize for these things, right? You don't want to pick these up front. But we knew that picking a database that wouldn't hinder our ability to build our application while we were building, but still being a good choice for the future and scaling into it, then that would be the perfect fit. So what ended up making our decision, though, is even though it was a greenfield new project, of course, engineering got started a lot earlier before we made the final database decision, and so they had built a lot of things on Postgres. So Postgres for wire compatibility became very important very quick. And storage is an open source project, and so finding somebody who shared that same vision and ethos that we could then promote was also an important differentiator for us. And then, of course, with your database, you want to know how well established it is, what's the ecosystem around, how long have they been around, right? You don't want to get into a relationship with a database and have to break it up later just because, because of consistency. So how did CockroachDB stack up? So this was as of 2019, so we've been a long time CockroachDB customer. This was kind of the roadmap of databases at the time. And so you have your traditional Postgres, Citus with sharding Postgres, Cassandra, Spanner, Yugabyte, TiDB. So all of those were options that were available at the time, and all of them kind of had little things that we were concerned about. And so, whether or not it was horizontal scalable, we've done the Postgres thing before, where you're uploading tens of thousands of operations per second and you start to rotate around transaction IDs. I don't know if anybody's ran into that problem before, where you literally do so many transactions that it can't vacuum them fast enough. So we've done that before. and also the default consistency layer on Postgres is not strong. It's not serializable. I don't know if anybody knew that. You actually have to set serializable as your consistency layer on Postgres. It's not there by default. And so there's a whole bunch of errors that you run into by default on Postgres if you don't set that. And Cassandra, for different reasons, they don't have strong consistency. Spanner at the time, obviously it doesn't meet our on-prem needs, and their Postgres wire compatibility was very new at the time. Obviously, the other Yugabyte and TiDB were very new or used MySQL. So I put on here, as of 2019, CockroachDB was maturing, which I confidently can say that it has matured now. But kind of, I'll walk through a little bit of the stories about CockroachDB and what we kind of went through. And so over the years, we kind of learned with Cockroach how to do things right and how to do things wrong. And so one of the things we did wrong at first was use Cockroach as a giant queue for a pub sub system, right? Where you just pop things in the front and pop it off the back and do that at 10,000 operations per second. And so, of course, we uncovered a lot of bugs back in 2019 and worked through with the Cockroach team on that. So they crawled over all over our bug tracker, as cockroaches do, and were able to fix all of the problems. And so that was a great success story in not only us learning how to use the database correctly and for the tools that it's meant to be used for, but also to have a great partnership with somebody that's able to work through the problems and be able to diagnose and fix them with you. So another success story that we have, as we learned with Cockroach over the years, was kind of a surprise feature that we didn't expect or a benefit, but actually was a big help in that we have used CockroachDB's time-traveling queries to help us debug application behavior, and we use it on a regular basis. So what happened was we had a specific bug in our application that we had no idea what was going on. What it ended up being was we didn't properly wrap something in a transaction in order for it to happen correctly. But we couldn't figure out what was going on. So we actually worked with the Cockroach team, and we are customers of the managed offering. They were able to restore a backup for us that we were able to do time travel on. So you could essentially just step and say at every millisecond of the database what was happening. And so we were able to use time traveling queries and step through our database and say, aha, the row on this table got written to before the row on this table. Something's not right. That should have happened in the same transaction. And so that was kind of a bonus feature. It was not something that we were looking for in a database when we were initially searching, but it's something that we were able to use and leverage to solve a critical issue that we had in our application. So just to kind of wrap it all up, kind of how did it go with CockroachDB and since we started in 2018 until now. This is one of our clusters. We actually deploy CockroachDB in 9 separate cloud regions, 3 in the United States, 3 in Europe, and 3 in Asia. And this is one of the larger clusters. So not like the biggest thing out there in the world, right? Obviously, there's people out there dealing with hundreds of millions of customers and hundreds of millions of things. So we got 5.1 billion rows, about 5 terabyte cluster, 5,000 read operations a second on average, and 1.2 thousand write operations per second. On average, and with bursts, of course, much higher than that. And so I put this image in the background too to just kind of show that we delivered on the promise of horizontal scalability as well. It's really nice when you have kind of those 10x events that just kind of sneak up on you as your company grows and you don't notice because all you did is you went into your managed CockroachDB cluster and clicked scale up a little bit and then you were fine. And so I think by the end of the year, all of this data is a couple months old. We'll have had another 2 or 3x load increase that basically for our operations team was nothing. And that's something that's really a tribute to using a managed service is we are able to focus on building and delivering our product and saving our customers bacon rather than managing and scaling a database. And so that was really a success story as well with CockroachDB. And this is the impossible. So this is the slide that answers the question at the beginning, did we make the impossible happen? Yes, we did. And so this is actual performance metrics of downloading a 1 gigabyte file from AWS, from Azure, and from storage. And so we actually went and uploaded all the data in Seattle which has meaning, Washington State for Azure and Amazon. You think if they had a region that was performing really well, it'd be those, right? Their home state. And so that's on the left. And so you can see if you happen to be downloading from Washington State, yes, S3 is faster than us, you're going just around the corner. But as you start moving how many thousands of miles away from Amazon, our object storage solution is up to 2 times faster than theirs and is globally consistent performance around the globe on our default storage tier, which is 80% cheaper than Amazon S3. And this same features and capabilities we have and can unlock multi-cloud storage for customers and also on-prem. So we did it. We did the impossible, and it's all possible because of CockroachDB being able to manage our metadata and be able to distribute it much like our data that's stored around the globe. And so just to recap, did we get our horizontal scalability we were looking for in those early goals? Yes, we did. Did we hit the performance goals that we wanted? Yes, we did. And we have the strong consistency that we need in order to run our object storage. And so kind of just final thoughts just to wrap up. Databases are hard to find a perfect database that does everything correctly. And so a lot of the time you work with your team to eliminate risk up front. You might have to ensure your data model is shardable or, work on your schema really hard to make sure you're doing everything right and use an ORM so you're portable across them. All of those are things that you could do with your database, or just use CockroachDB to start with. And then you've covered getting started easy, familiar syntax with Postgres. You're able to develop your application quickly and get started. And then when it does grow and you do hit those scaling events, you don't have to worry because you're able to add capacity as you need and know that the sharding and performance will just scale with the size of your cluster. And that's all I have. So thank you very much.